Hi everyone, this video is a quick review of measures of central tendency, mean, median, and mode, and a review of measures of variability, such as range, variance, and standard deviation. These measures are used to study or describe a population or a sample. So let's begin by defining the terms population and sample in the context of statistics. In statistics, a population refers to a group of people, a group of animals of a certain species, trees, whatever you're studying. It always refers to all members of this group. We consider this group in its entirety. For example, a population could be all the students in a country, all the students in a city, or all the students in a particular school. You define what the population you want to study is. Whereas a sample is always constituted of a few members of this population, the population we want to study. So why do we pick a sample? Let's imagine we want to study the level of satisfaction, the level of well-being of all the students in a school, but we don't have time enough to ask them all how they feel. Then we can just take a few students and ask them. Suppose we ask all the students in that sample to rate their level of well-being from 1 to 5. Then we could just take the mean, take the average rating, and use that statistic to describe the level of well-being among students in the whole school. So I hope that now you understand what population and sample mean in the context of statistics. Population refers to all the members of a group under study, whereas a sample is when you pick only a few members of this group, of this population, oftentimes because you don't have enough time or financial resources to measure every single individual in the population or ask them about a specific topic. So let's get back to our measures of central tendency and variability. Suppose we are given the following collection of numbers, 5, 12, 8, and 3. We have 4 numbers. Therefore, n equals 4. N is the amount of numbers in our collection. And the mean would be the sum of all the numbers in that collection. So 5 plus 12 plus 8 plus 3 divided by n. That would give us 28 divided by n. 28 divided by 4 is equal to 7. Therefore, the mean is equal to 7. That's how we calculate the mean. Now, let's say this collection of numbers is our data on a given population. The variance of this population would then be equal to the sum of the squared differences between each of these values and the mean divided by n. The variance of the population would be equal to the squared difference between 5 and the mean, 5 minus 7, plus the squared difference between 12 and the mean, plus the squared difference between 8 and the mean, and the squared difference between 3 and the mean. And we divide by n. But there's another variance, a variance of a sample, and instead of dividing by n, when we calculate the variance of a sample, we divide by n minus 1, and I'll explain this later in a future video. So let's get back to the variance of the population. If we calculate the square differences, that would give us 4 plus 25 plus 1 plus 16. 5 minus 7 is 2. 2 squared equals 4. 12 minus 7 is 5. 5 squared equals 25, etc., etc. And then we divide by n. Remember that the calculation is done first between the parentheses, then the exponents, then multiplication and division, then addition and subtraction. So this gives us 46 divided by n, which is equal to 11.5. 46 divided by 4 is 11.5. This is how we calculate the variance of a population. And as you may have guessed, we need to calculate the mean first, because we need a mean to calculate the variance. And the standard deviation is pretty straightforward. It's just the square root of the variance. We take the square root of the variance. The variance is 11.5, and if we take the square root of 11.5, that gives us 3.39. So the standard deviation is easy to calculate. Let's now pay attention to the following lists of numbers. We have two lists of numbers, and these numbers are arranged in ascending order, as you can see. But we don't need to pay attention to order to identify the mode, because the mode is just the most frequent number in the list of numbers, regardless of order. It doesn't matter if the numbers are arranged in ascending or descending order, or if they are arranged, or if they are not arranged in any specific order. The mode is the most common number you'll find in the list. So in the first list, the mode is 15, because 15 appears 2 times, whereas the other numbers only appear once. And 15 is also the mode in the second list. So the mode is 15 in both cases. But to identify or calculate the median in a list of numbers, we need these numbers to be arranged in ascending order. They must be arranged in ascending order. There's two ways to calculate or identify the median. If there's an even amount of numbers in the list, then we take the two numbers in the middle, in this case 9 and 12, we add them up and we divide by 2. So we average the two middle numbers. That gives us a median of 10.5. And when there's an odd amount of numbers in the list, the median is just the middle number. Here we have 12 as the median, because 12 is the middle number. And finally, calculating the range is pretty straightforward. The range is the highest number in a list minus the smallest number. So if we take this list as an example, the highest number is 18 and the smallest is 3. So the range is 18 minus 3, which gives us 15. Why do we need all these statistical measures? Because there's no single statistical measure that will give us enough information to describe a population or a sample. And for illustration purposes, let's take the math grades in a given class A and compare them to the math grades in class B. In class A, we have the following grades. We have 6 students, and we can tell that all of these students are pretty much average at math. Whereas in class B, we also have 6 students, but half of them are very bad at math, and the other half are excellent students. And yet, when we calculate the mean, we get 12 in both cases, which tells us that the mean doesn't explain us everything. The mean doesn't tell the whole story. We need to combine the mean with some other statistical measure to get a more detailed picture of what's going on. For example, we can calculate the variance, which is going to be much higher in class B than in class A, because the variability around the mean is much higher, which tells us that most students are either good or bad at math and very far from the mean, whereas in class A, most grades are very close to the mean, and therefore we can deduce that these students are average. They are not bad, but they are not geniuses either. And finally, a quick review of mathematical notations for the mean, the variance, and the standard deviation. These notations will differ depending on whether we are talking about the population or a sample. The mean of a population is usually denoted by mu, the Greek letter mu, whereas the mean of a sample is denoted by y bar, x bar. There will be a bar on top of the letter you're using to represent the variable. The variance of a population is denoted by sigma squared, so the Greek letter sigma squared. The variance of a sample is denoted by s squared. The standard deviation of a population is denoted just by the letter sigma, so we removed the square, which makes sense because the standard deviation is the square root of the variance. We do the inverse operation of squaring. And the standard deviation of a sample is denoted by the letter S. This is the end of the video. If you liked it, if you deem my video useful, then consider subscribing to my channel, liking the video, dropping a comment. That would incentivize me to make more content like this. Thanks for watching and see you next time.